What's up, everybody?
Hello.
How's it going?
Hello.
Pretty good. All right. Oh, hey, Matt, I just have a question. If you're there. Oh, he is not. All right, I'll give people another minute or two to join. Not sure if I wonder if Debbie usually talks before this, but I don't see her. Let's see here. Hey, what's up, Mia?
Hey.
All right, what's up, everybody? We're gonna do some coding. It's gonna be great. So yeah, Debbie usually talks before these things. I'm not sure where she's at, so I'll just go ahead and start. So today is going to be a little different than kind of the past ones. I wanted to this time kind of do a group problem solving adventure and try to tackle a couple of more beginner level coding puzzles, as well as just kind of coming up with some solutions and then talking about it, and then seeing how we can, if there's maybe ways to optimize it or maybe make more like general cases of these things. So that's kind of the goal of today. Does anybody have any questions before we start? I'll take that as a no. Cool. So, share my screen here. Okay, so I have just set up some little test cases here. Okay. So today's challenge is I've got three functions that we're gonna write, and the goal is to or I should say there's three challenges that we're going to solve using some functions. I kind of stole these from Edibit a little bit. I kind of, no, I straight up stole them. I was going to say I sort of did my own, but I'm using my own test cases, but these are all just from Edibit. If you haven't used Edibit, it's pretty rad. Edibit. I highly recommend doing any sort of coding challenges regularly. This is like really where you become fluent in the language, in my opinion. Anywho. Okay, so we've got three functions here. Hopefully we'll get to all of them. And if we get through all three, then we'll maybe tackle some more. You guys are pretty smart, so I bet we'll finish these pretty quick. So, okay, the first thing we're gonna do, first function is a factorial. Is anyone not familiar what a factorial is?
I could use a refresher. I admit it.
Sure. So in a factorial is just a mathematical operation that you perform on a number. So, for example, 3 factorial. Yeah, write this in notes. Can you guys see my screen okay?
Yeah.
Cool. All right. So, for example, 3 factorial, which is denoted as the exclamation point. This is the equivalent of 3 times 2 times 1. 5 factorial would be 5 times 4 times 3 times 2 times 1. And the 1 is kind of redundant because anything multiplied by 1 is itself. So effectively, you're basically just multiplying a number by all of its succeeding numbers down to 1. One thing to note, though, 0 factorial is 1. Just so you know. I'm not going to go into why that is the case. There's a very rigorous mathematical explanation for why that is the case, but we're not going to talk about it then. We'll just assume that that is true, which it is. 1 factorial is in fact 1. 2 factorial, of course, is 2 because it's 2 times 1, etc. Does that make sense? Does anybody have any questions about factorials? Cool. We'll comment that out for some notes. Okay, so the goal here is to write a function called factorial, which given a number will produce the correct number, which is the factorial of that number. And one thing, negative numbers, we don't have to worry about negative numbers. In fact, I don't really know if there's a definition for a negative factorial. So we're going to assume that it's a positive integer or 0. Those are the possible range of inputs. So, all right. How might we approach this? I'm gonna use the Socratic method a lot today to try to coax your brains a little bit. So how might we start this? How might we start this? Anyone have any ideas? We're talking big picture here, like bird's eye view. Anyone want to volunteer? Don't be shy.
Wait, did you say like how to approach it?
Yeah, like how might we, before we actually code the thing, how might we if you were to explain to someone the solution to this problem, how would you do it before we actually code it?
I think we would probably need to like either use some kind of recursion or iterate through like basically the input value.
Yeah, that's a great observation. So you notice that there seems to be a pattern here where whatever the number is, we need to do some sort of repetition from the number we're starting with down to 2. So that's a great observation. So, and you're also right, recursion could work. We can also do it a more traditional we can also use a more traditional loop as well. So we know that we're going to have to, whether we're recursing or looping or whatever, we know that we're going to have to we know that we're going to have to repeat a sequence of multiplications. All right. So we need to somehow get from this number, loop through all the digits, or sorry, all the integers between that number and 1, and somehow arrive at the answer. So how can we do that? Where do we go from here? So we know that we're repeating a sequence of multiplications. How might we set that up?
I guess we can start with the basic case. If it's 0, return 1.
Yeah, that's a great point. So we know that if it's 0,
I guess 0 or 1.
yeah, if x is 0 or x is 1, then we're just going to return 1. That's a pretty good start. We could do some fancy logic to like somehow put that into our for loop, but I think this just kind of weeds out some of the weird ones from the very beginning. Cool. So how might we set up this this looping situation? So I'm going to show you the recursive one later, but we're not going to worry about recursion right now because that's a little bit more advanced than we need to go right now.
Yeah, I mean, I think you could just do like a for loop, and then basically whatever the x is.
Okay.
Well, we want to, so the number is going to start from like, oh, actually, I'm not really sure. Basically, we only want to go up to the point where it's either like, we want to stop at 1 or 0.
Right. So what if we started at x and then went down to 2?
Yeah. So do like let x, or like, yeah.
So
I is equal to x or something.
Beautiful. Okay. And then what?
And then as long as it's great, as long as it's greater than, this is where, would we say 1 or 0?
Yep. Yeah. 1. We could do 0, but then we're just multiplying. We're just doing one extra iteration that's kind of unnecessary because multiplying by 1 is redundant.
Oh, okay. So yeah, and then just I minus.
Yeah, awesome. So okay, cool. So we know that now this loop is going to we know this loop. Oh, hey Emily. We know that this loop is going to go from x down to 2. Okay, so now the question is, all right, how are we going to, we somehow have to arrive at an answer, right? How are we going to store this answer?
As a variable?
Yeah. So why don't we just do let output, and we'll start it at 1. it doesn't really matter. Yeah, one makes the most sense, because what we can do is every iteration, every repetition, we're just simply going to store output as itself multiplied by I. Does that make sense? So when we start, so it doesn't really matter what we initialize this value as, to be honest. But I think one makes sense. We could do 0, I suppose. But what we want to do is we want to store output as output is basically becoming our running tally. So in our first iteration, let's say x is 5, then we're going to set output equal to 5. And then it's going to be, the next iteration is 5 times what the next sequence is, which is 4. So 5 times 4, which is 20. And then times 3, which is 60. And then times 2, which is 180, etc. So we can just say output is equal to output times I. And then after it goes through that sequence, you can simply return the output. So I've written a series of little test cases over here. I'm going to worry about. So, wait 1 second, sorry. Okay, so I wrote a couple of unit tests here. So what I've done is I'm going to assume that we've got our inputs over here. Oh, and these are actually reverse steps. That's supposed to be. There we go. All right, I had these backwards. Okay, so basically I've just determined, okay, these are the cases I want to test for. I want to test for the factorial of 0. I want to test for the factorial of 1, and I want to test for the factorial of 10. And I could add 4 if I wanted to, or however many I want. And then up here, I just have an array that corresponds to what the expected output should be. So for 0, I expect it to be 1. The factorial of 1 should be 1. The factorial of 10 is this number, obviously. And then factorial of 4 is, well, 4 times 3 is 12. 12 times 2 is 24. Cool. All right. We're going to run this test. Let's see if our function works. Hey, check it out. Totally passed. Sweet. Okay, does this make sense? Does anybody have any questions about this?
We had a couple of comments in the chat. I don't know if we touched on those.
Let me see. The thing I hate about Zoom is while you're screen sharing, it can be kind of hard to see the chat. Okay, here we go. So since we aren't using recursion with those, the first statement you refer to as edge cases. Yeah, you could certainly consider those as edge cases, because they're kind of unique in a way, where those numbers, if x is 1 or 0, then it doesn't really need to be ported through that loop. So like in a sense, yeah, we're just checking for a couple of edge cases. Now, normally, like, you want to be able to handle edge cases as elegantly as possible. So it's not just like arbitrary. This, though, I think is, I would argue that's pretty elegant. Because those are really the only two edge cases. What we could do, if we wanted to, is if we wanted to make this function even more like robust, we could test if x is less than 0 and throw an error and say like, oh, hey, negative numbers aren't allowed. That would certainly be an option. And that you could also consider that as a certain type of edge case as well. So yeah, that's a good point. Okay, cool. So, all right, that's how you would solve it using just a normal for loop. There's a lot of different ways you could do this using a for loop. However, let's think about how we might do this recursively. So, has anyone who here has never used recursion before? And it's totally fine if you haven't.
I don't think I have.
Cool. Recursion is really awesome. Recursion is just the ability to call a function within itself. So in this case, if we're going to use recursion, that just means that in the block of this function call, we can actually call the function itself. So basically, recursion is just this idea of a function calling itself from within itself. It's very meta, very Zen-like. There's a couple of things you have to be careful of, though, and I may do like an entire episode on just recursion because it's a cool concept. But there's two things you just have to be careful of. So the first rule of recursion, obviously, is you call the function inside of itself. The second rule of recursion is you have to have what's called a base case, which is a way out, meaning a way to stop the recursion. Because if you were to just let it go forever and ever, then you've got yourself a problem because your program's never going to end. In the words of Alan Turing, it won't halt. The program will not halt. So that's the most important thing about using recursion, is that you have to have a way out of the recursion. So in our case,
are there specific cases that you want to or need to use it, or is that just like a preference sort of thing?
Are you asking just like using recursion generally?
Like when you would, sure.
So, okay, so if I understand your question, you're asking like, is there a particular time when recursion is like either necessary or recommended?
Yeah, like, oh, this for sure needs recursion.
That's it. Okay, so that's a really great question. So technically, recursion and looping are logically equivalent concepts, which means that there's nothing that you can't do with one that you can do with the other. There is a trade-off. When you do recursion, you actually end up using more memory because you're actually using the call stack because they're function calls. So if that is a concern, like if you're concerned about like using too much space on the call stack, then recursion may not be what you want to use. However, recursion is really, really, really great for doing things like traversing across a wide area of possibilities. Looping is too. Again, they're equivalent concepts. However, it can actually be more intuitive to use recursion in certain cases. So like if you're trying to crawl across a vast tree or like web of nodes, recursion can actually be really intuitive for that purpose. Whereas if you're just doing like a very linear sequence, a loop is probably just fine. In this case of factorials, that it's honestly kind of sixes, although the recursive solution to factorial is super elegant and is really cool looking. And I think it's really awesome just based on that, because check it out. It's this is how you do it. So what I'm gonna comment out our loop here, and the solution. Does anybody have an idea of how we might? I think actually, Giovanni, I think you put in the answer earlier, but without cheating and looking at the chat, does anybody have an idea of how we might use recursion to solve this in one line?
So we know we have to call the function, right?
Yep. So we know we're gonna have to do something like this inside of this block.
And I guess our goal is to, like it says, kind of in the at the top, we want to return a number and have it get smaller every time.
Mm-hmm. What do you imagine going into the argument of this function?
Some output,
Say that again.
some output.
Not an output. If we know that this number x, let's say it's 5 or 10, if we're calling factorial inside of here, what do you think that number is going to be? Based on this pattern that we already know about up here. Another way to ask this question is, I have some number. If it's 0 or 1, I'm simply going to return 1. Otherwise, I'm going to multiply this number by what? If this is 5, what am I going to be multiplying it by next?
4.
Yeah. So how do we represent that? Again, that could be 10, that could be 20, that could be 30. How do I represent one less than that number right here?
Something like x minus 1.
Boom. Okay. We're not quite done, but that's kind of the core idea here. What am I? So what do I do with this? What do I do with this value? I know that this number, let's say it's 5 or 10, whatever it is, I'm multiplying this by what?
Like one less than what it was, right?
Yep, exactly. So we're just going to simply say return x times the result of the factorial of the next lowest number. And this pattern then will recurse over and over and over again until it hits that base case. And to me, this is just really cool. I love this. I love the elegance and simplicity of this right here. It's pretty crazy. Let's see if it works. So I'm going to run my test again. Hey, look at that. It worked. Beautiful.
Hey Ben, if you
Yo.
don't mind, I'd love to hear why Giovanni went first for recursion, why that was his initial like method to go to, as opposed to the kind of the way we did it first. I'm just wondering if I'm wondering about the train of thought that kind of led to that being the primary method to use first.
Sure.
Yeah, maybe Giovanni, you wanna answer that?
Yeah. So based actually on Emily's question from before, I find that maybe you will understand. You won't understand now, but just keep it on your mind. Is that recursion? I don't know. Some people say that you don't need to use recursion as a web developer, but lately I use a lot of recursion because always when I find something that is nested and I don't know what is the end, like for example, I don't know exactly the end of that structure, so a nested structure, then recursion is it's not just elegant, but it's the first thing that comes to my mind because it seems easy. Because I believe if I don't use recursion, I will have to use a helper function and then mix both of them and call them. So it will be harder. So in this example, when we have to go from like 5, 4, 3, 2, then a for loop is probably more simple because it's the first thing that we learn. But the more that you practice recursion, I believe at least in my case, it seems more straightforward. It's more readable. It's like when somebody asks you for how to get from one point to another point. Like the for loop is more like very verbose. You say you have to go northeast, and you have to go north, and you have to go east, and you have to go 2 blocks, and something like that. But recursion is not like that. You don't have to be very verbose. It's more like in real life. It's more straightforward. Like it's more compact, but the more that you practice, it gets more easier. So yeah, that's what I use recursion. I hope I articulate my idea right.
Cool. Yeah, I tend to agree that the recursion can tend to be pretty elegant and compact for sure. Sometimes though it can be pretty complicated. This is a simple example, but yeah, in general, recursion can be super useful. I think it's a really important concept to know. Cool. So let's move on to the next one. This one is called the largest digit. So that means that we're giving it a number, whatever it is, and this function is simply producing the largest digit in that number. So to look at our test cases, so the numbers that I've chosen to test are 0, 21, and this number, this big number. So obviously the largest digit in 0 is 0. The largest digit in 21 is 2. And then the largest digit in this big number is 9, because there it is right there. And we could do other ones too, like, I don't know, 435, that would be 5. Cool. So any questions about at least the goal of this little challenge? Cool. All right, well, how do we go about doing this?
So we're trying to find the largest number in that array.
The largest, not the largest number in the array, the largest digit. So if I'm given a number
gotcha.
like 4,346, then my function should produce 6, because 6 is the largest number, or the largest digit, I mean.
Oh, gotcha. At first I was, okay. Yeah.
Yeah, this array is just there so that I can easily put in inputs that I want to test, and then I'm checking, and these are the answers that I expect them to produce.
Okay, so I have an idea, but I'm on a real kick right now with this method. Would you want to use reduce, or could you?
Reduce. Let's see here. You could use a reduce. I'm not sure. Yeah, and you could definitely use reduce. There's actually a cool thing you could do with that. Yeah, I actually like that. So where are you going with that? How might we use reduce to accomplish this?
I was just merely suggesting it. I don't know if I want to. No, I'm kidding.
What led
So
you
would,
to?
so it's kind of well, when I just quickly glanced at it, I know that you would want to. So basically, you have the test case is an array, right?
The test case is a single number.
Oh, you're not gonna.
We're
so
testing. We're just checking whether or not, or we're just checking what the largest digit is in a number.
Okay.
Yeah, that array was an array of possible
Yeah,
numbers
don't
you could use.
ignore the
But
fact
you
that
could
this
still
is an
do
array.
that technically, right?
Oh, absolutely. You could absolutely use reduce. You would somehow have to go from a number to an array-like structure, which
Right.
you can
So
absolutely could do.
okay. Well, then you would need to have a final number and a current number to work through the number given.
What would the final number like kind of represent? Like what are we reducing to?
The largest digit.
Yeah, exactly. Cool. All right, so let's at least set this up. So we have to somehow go from a number to an array. How might we at least do that so we can at least get it into a form that we can work with?
Spread operator.
Say that again.
The spread operator, right?
No, that's not going to help us.
Could you set up a variable? Well, I guess you kind of already have one.
The question is, how do we go from X to an array of digits? How do we do that?
Right. You need a function, but this is already set up. So I've never come into using reduce, I guess, within an already existing function.
Well, we already know.
I might just be out of my league here with the idea.
No. You're on the right track. I like where you're going. But all I'm saying is that first of all, in order to call reduce, we have to have an array first.
Mm-hmm.
So the question is, we have the first problem is how do we convert a number, a single number, which is the data type number. How do we convert that into an array representation where each index is its respective digits? So for example, if I have 4,346, I need to somehow go into, it needs to somehow be this.
Right. So are you talking about wanting to put an empty array are you talking about like the third condition or, because you need your final number, the current number, and then you need what data type you want it to be, correct?
Let's not even worry about what the reduce method is doing yet. We can't even call reduce until we have something to reduce on, and you can only use reduce on arrays.
So then you need to put a number into an array.
Mm-hmm. How do we do that?
I don't know. Without like Googling real quick.
We need to have an array to push the numbers into, right?
There's actually a very elegant way of doing it. It's a very clever way of doing it. If
Cameron says split in the chat.
Say what?
Cameron says split in the chat.
Yes. So that's half of it.
But then aren't you just adding like another method into were you thinking, I didn't know that you could you just use as many methods as you want in like one function?
Absolutely. We need to go from, so split, we all know that split well, maybe I shouldn't assume that we all know that. Split is just a method that, that converts a string into an array. So that goes from like, you know, if I have a string ABC, split will do this. Which is halfway to where we want to go. How then do we go from a number to a string so that we can then call split on the string?
ToString.
Yeah, that'll work.
Arnold said that.
Beautiful. So yeah, we can totally do that. We could say x to string, and then we can split. So let's get our array. So let's see what that looks like. I'm going to put a breakpoint in here, and I've already got my test running, so I should at least be able to see something. My debugger's being a I just want to be able to see it. All right, well, I'm not sure why it's not letting me do that. Oh, well. Okay, anyways. So this is, go ahead.
We're missing the quotes inside split.
Oh, yeah, here, that's a good point. That will allow us to split by each character as opposed to the entire string. And yeah, you're gonna look that method up on MDN if you wanna learn more about it. Cool, so now we know that we've got this array that basically went from, let's say that's the number 5,273. Well, that's now gonna look like what did I say? 2073 or something. So that is how you go from a number to an array of its digits. Okay, so now Emily, we can do your we can go back to your original idea, which is to now that we have this array of strings, which are representations of each digit, now we can call reduce. So the question is, what does our logic look like here? We know that the first argument is total, and the second one is our current digit. So I'm going to use D for digit, or I'm just going to call it digits, and then we know.
Sure. So then, so you're saying T is the what? Sorry, what was that's the total that you want to get, correct?
Yep. So this is going to be the equivalent of the largest.
Okay.
So I'll call it largest, so that way it's clear.
So then we would say the largest would, you've got to go and have the largest compare to, you have to compare all the digits to each other.
Yeah, exactly.
So
and we know that
plus equals digit.
Plus equals?
Equals plus.
How do we compare whether or not the digit that we're on is bigger than the largest one we've found so far?
An if?
Yeah, exactly. However,
so if largest.
Yeah, so if we write this out just in plain English, we have to say if the current digit is larger than the current largest, then what? What do we do?
Make that the current.
Yeah, exactly.
Digit.
Make that the new largest number or digit, I mean. Otherwise, we don't do anything. We just keep on keeping on.
Right.
Cool. So our logic now, it seems like all we really need to do is just say, okay, if digit is greater than largest, return digit. Otherwise, return largest. Right?
But I'm
Does this-
assuming it's not quite that simple.
Does this sound reasonable?
Yes.
Yeah. There's a subtle problem with this expression, right, as it stands right now. Does anyone figure out what that is? In fact, for now, let's run this and let's see if our test passes.
Is it because some might have the same, like in 4,346, there's 2 4s?
Well, so it passed. It actually, oh wait, no, it didn't pass. I forgot to take out my. So remember, we're only comparing one digit at a time. So the question is, okay, so now I've got a failure. This should actually tell you a lot.
So a number can't be more than or less than itself.
Not quite. So let's go back to this guy right here. That's an array of what? What data type does that array contain?
Characters.
Say that again.
Characters.
Yeah, the characters. Well, so they're strings. The data type, they're strings.
Yeah.
Right. It looks like this, although they're of course numbers.
Oh, so because it's a string itself, like you can't compare if it's greater than or larger?
You can, but there's some subtleties there. So this 1 is less than 2, as opposed to the string is less than 2. Those are subtly different expressions. Now I believe that these are both going to end up being true because of the way that JavaScript type coercion works. But you got to be careful because, for example, now in our case, it's not that important, but right here, for example, let's do. To think of an example. Oh, so like 23 as opposed to 100.
Well, I'm just gonna keep taking shots. Do you have to convert it back to a number?
Boom. That's it right there. So there's a couple of ways to do that. We could use the number constructor to do that, like that, for example. There's also a shortcut that I prefer that I actually really like, which is just to put a plus sign in front of it.
But I don't think largest need the plus, right?
It does. Well, technically it doesn't. We could, because at the end of the reduce, we can just put the first item. You could do that, or you could just do
Because by default it's 0, right? And now,
no.
no?
We could do that, like that. We could set it to 0, for example. However, the problem is if we pass in an empty array, then we don't want it to be 0. We want it to be, potentially undefined. But actually, before we even get to there, let's think about, we know that this is a string, and we know that that's a string. So we have a couple options. We could either do the number conversion maybe up here somewhere. We could do like a map to convert everything back to a number. That would be an extra that would be an extra loop that we, isn't really necessary. So doing it here allows us to just kind of kill 2 birds with 1 stone. Because remember, on the very first repetition, this is still a string. So we have to handle that.
Is the plus sign like a shorthand operator to convert a string back to a number?
Yep.
What about if the number is negative?
Say what?
What about if the number is negative 4,346?
So then it won't. So I should have stipulated in the beginning that that we're only talking about positive numbers. But if we did a negative number, then we could easily just splice off the hyphen that gets created. Because, for example, if we go to, let's just see, so it's easier to.
I also feel like, didn't we learn, or I learned this parse int? I thought that was the way you turn a string to a number.
That also works too.
That
There's
works.
several ways to do it.
Of course.
So let's look at just some clear examples just to kind of see what we're dealing with. Let's do, let's say I have a string. It's 1, 2, 3, and I put a plus sign in front of it. Okay, that gives me a number. You can tell it because it's all purple. Okay, let's see what happens if I convert a negative number to a string. Let's see what that looks like. Oh, I gotta put a parentheses around it. Okay. That doesn't really represent it very well. Let's do, this way was a little easier. Okay, check it out. Okay, notice there's now that hyphen there.
It like stopped sharing your progress on your screen.
Oh, I know why. Sorry, let me,
Okay.
I just realized I was only sharing the one screen, not my entire. Okay. How about that? Can you see this?
Yes.
Cool. All right. So as you can see, when I did my, let's do it over again. So here's the string 1, 2, 3 with a plus sign in front of it. It gives me a number. Beautiful. Okay. Now if I do, let's say, string to a negative number, okay, that gives me this guy. Okay, so that means that look what happens when I do a split. What do we get? Okay, so see that extra character there? That's no longer that's not really a digit anymore. So in our example, if we were dealing with negative numbers, we could easily just, filter that hyphen out if we wanted to.
Ben,
Yeah.
interesting enough, actually, it works with negative. It makes it negative. When we put plus in quotes negative 123, it gives you negative 123.
When you do what?
Plus, and then between quotes, negative 120, 123.
Oh,
Yeah, it works.
Oh, that's cool. Yeah, so that gives us, oh, that's awesome. And I've never actually tried that before, so that's cool.
That shouldn't work.
Say what?
I said that shouldn't work. That makes no sense why it works.
It makes sense that it would work. Because if I were to do something really crazy though, like let's say I try to convert like just nonsense. See how that's just not a number?
Can you
But
tell me how it's working underneath the hood with that plus sign? Is it like an actual just like number, like the global object number, or is it like coercing it or something like that?
I believe it's coercing it. I don't think it's using the number constructor, but that is actually a good question. I'm really not sure.
Okay.
Because interestingly, doing this also, I mean, I would expect that to work. So I need to read up on that because I'm not exactly 100% sure on that. That's a good question though. Okay, so we've gone down quite a rabbit hole, but that's awesome. That's what's fun about the coding. So let's take a step back and kind of look at what we've got so far. So what we've done is we've converted an array into a string or into an array of string integers, which represent each digit in the number. We're then reducing it, meaning we're looping through and we're only outputting the largest digit at every repetition. And we're basically taking the string and we're converting it back into a number every time. And oh, I forgot to do this. So, but one thing I wanted to point out is I want to look at this expression right here. Because suppose we have a situation where there's 5 is less than 2, or sorry, 5 is greater than 2 is a much different expression than 5 string is greater than 2 string. They both happen to be true. Let's see what happens if I do this. Okay, all right. So it looks like JavaScript is coercing our data types the way we expect. However, what happens if I do this? Does that look like a problem?
Yeah, it only works with one digit.
Yeah.
It as like it's gonna have its length is bigger, right?
So yeah, like this right here, this string, while 50 is certainly greater than 2, when the fact that they're strings screws with this operator. The operator treats strings differently. If you want to learn more about that, then MDN's got a really great article on it, but basically it has to do with the fact that their digit or the number is they're not getting compared as numbers, they're getting compared as strings. And the number that they're using from a string is different than the number that they're represented as a string. So in this case, they're not actually comparing the number 50 to the number 2. What they're doing is they're comparing the I forget what it's called. It'll come to me in a minute, but
it's not length of string, is it?
No, they're not comparing the length of the string. That's a good guess. What they're doing is they're comparing, I believe, the Unicode value of the string. So, or sorry, ASCII, not Unicode. Yes, thank you, ASCII. That's what's getting compared. And so that's why you got to be careful when you're using this, when you're using the greater than or less than. Don't assume that it's going to do, that it's doing what you think it's doing. If you're doing numbers, then yeah, like 50 is obviously not less than 2. However, you know, obviously this is that's a, oops. Like that is a problem. Wait. Did I? No, that's right. Wait, did I just, okay, in my head, I think I looked at that differently because that is the right answer. 50 is, it is not true that 50 is less than 2. That's correct. I got it mixed around in my head. But anyways, you just want to be careful when you're using this operator. You really only want to use it on numbers or if you know exactly what you're doing. So what we've done in our case is we're saying, all right, if the digit that we're on is greater than the digit that we found to be the largest, then return that new number. Otherwise, return the largest. And what we might want to do, just so there's a lot of redundancy with these pluses, so like it might not be a bad idea to do this. And then you can just make the comparison like this, and then it's a little bit you're doing less operations, but those are some options. There's a lot of different ways to do this. This actually wasn't the way that I was planning on doing it, but yet again, another reason why reduce is my favorite array method.
Thanks to Emily.
Say what?
Thanks to Emily.
Yeah. Thank you, Emily.
If we console log, because I don't use reduce that much, if we console log largest the first time, what is largest the first time?
Largest is going to be the first element of the array by default. If I were to put in I were to put in 0 or something right here, then it would then be like, oh, you want me to do this number. The reason why I'm not doing that is specifically so that we only care about the first item in the array. Or this way, we're just starting on the first item, basically.
Okay, makes sense.
Yep. Okay, cool. So let's test this. Let's see if it works. So I expect 0 to output 0, 21 to output 2, this big number to output 9. Oh, we got a failed test. Received 3. Oh, that's interesting. Oh. All right, something wrong with our logic. So notice it's saying that it expected 5, but we got 3. Let's see what we did wrong. Oh, I did this backwards. If our digit is greater than the largest, then return the digit other way to the largest. That's, oops. All right, this should work. Cross fingers. Oh no. Oh. Aha, okay. So notice, so all of them worked except for this guy. And notice the problem is that our expected value, which is the number 0, we are given the string 0. So that's interesting. So that means that if our value is 0, really, and in fact, I bet it would do the same thing if I did even just any number with 1 digit. I believe this is the case with all of those. Let's see what's causing that. I bet you this should fail too. Yeah, exactly, same exact reason. Okay, so this is because we could give it a value of 0. However, like we could probably do this, but the problem, actually, no, that wouldn't solve it because I don't think that would work. Because the thing is what if we put in, let me think. this does work, I'm gonna have to think about why that works. Okay, so that works. Oh, I know why. Okay. Yeah, so that works because we're starting on 0, but then we start from the beginning of the array. So if we don't initialize it like this, then so basically, because there's only one digit, it doesn't really get a chance to loop through like the whole thing. Like there's not anything to loop through. There's just one digit. So the reduce will just simply automatically output the first member of the array, which is our digit. And so we never actually get the chance to convert that number to, or sorry, that string to a number. So there's two options. One, we could initialize it with 0. Or the second option is we could just convert the output to a number. That should also work. Boom, that works too. So whichever one you prefer. I personally like this one. But you know, again, there's always lots of different ways to do the same thing.
Why do you have to convert that variable and still have to convert the digit and largest?
That has to do with just the way that reduce works. If you're reducing through an array that only has one item in it, so the problem was that we had the problem where if my number that I give it only had one digit, so 0 or 1 or 5 or whatever, then that means that our array only has one item in it. And if you call reduce on an array with only one item in it and you don't give it a default value, then it just automatically outputs that single member. Does that make sense?
I might not have asked like the best question. So if you put that little plus sign on the variable in the beginning, when you save the whatever, then why do you have to then also put that plus sign on the digit and the whatever the other one was?
So
why do you have to have it on line 27 in front when wouldn't that basically say that that whole array is now number?
Sort
why
of.
do you also have to have it on 29 and 30 for digit and largest?
So there's actually two things happening here. So one, let's look at if I write reduce with just one item in it. Notice how I'm not initializing anything here. Like I'm putting in my callback, but I'm not having it do anything. But the key here is I'm not giving it an initial value. So I'm not initiating it with anything. If you don't initiate the reduce with a value and your array only has one thing in it, then it will automatically output that item. Notice how I don't have any logic in here whatsoever.
Okay, I see what you're
And
saying.
I'm still getting I'm still getting my string value 1. What that means is that no matter what my logic is inside of here, none of that's getting applied. Therefore, putting it in front of my reduce expression gives me, it handles this particular case. Now, if I have several things, let's say my number was 12, well, now all of a sudden I've got a problem. Well, it's not really a problem. It's just that now having that plus sign there is not really relevant because there's multiple items in there, my callback now actually has importance. Like it's actually, so for example, it's just, so let's say I do like, I don't know, times 2. Right. So there's my thing right there. There it is. So it just has to do with the fact that in some cases, namely when the digit or when the array only has one thing in it, the reduce basically ignores that callback. And so putting that plus sign there is basically like a safety. It's like it just adds an extra layer of safety. Does that make sense?
Yeah, totally.
Yeah. But effectively, this effectively will also solve it. And for it, it solves the problem, but for a different reason.
Can we add the plus, not the plus sign, but in any way, can we make all the elements numbers? Maybe, what do you think? In line 26, would be better to just from the beginning to have an array of numbers instead of strings, so we don't start doing plus everywhere.
Yeah, I mean, you have, that just means that you have to do one extra loop, but I mean, you know, it's kind of whatever. Like, for example, here's an example of how we can essentially do all that work. So now we can simply say, let's do largest in digit, and now all of a sudden I've got a much more compact function.
And then we don't need 0, right?
Do what?
We don't need in line 31 the number 0.
Exactly. And now that doesn't matter. And now, and in fact, we can even make this, even more compact, where we can say, this is why I love reduce. So I'm gonna make this look crazy. So if our largest, sorry, if digit is greater than largest, then return digit, otherwise return largest.
Yeah, I like that way. That way better.
And then if you want to make it even more compact, you just do this.
I didn't like that move.
I don't like this, but I mean, I like it, but I also hate it because it's impossible to debug. But anyways, yeah, this actually, I generally don't like doing it this way, but just to give you an idea of how chaining functions is actually kind of cool. So that should work. Let's just run and make sure.
I believe it's important to see that it's an array.
Yeah.
Like the way before, one step less, even that is less, one more line.
Yeah. Yeah, I agree. I am a fan of having your code be more readable than anything. This is not very readable.
Maybe if you're
Cool.
just making up your own pleasure project.
Exactly. All right, we got one more function left. One more thing.
I have a question.
Go ahead.
So I'm just curious if you could, I guess, go through this next little challenge in the format of if you are the employer and
Okay.
you're challenging somebody. So I'm just interested in seeing the format of that and how you would go about that.
Okay, so like as if I were a hiring manager and
Sure.
you were the candidate.
Yes, but I'm not.
Would you like to volunteer?
I just want to know how you would go through it.
So, to be honest with you, a hiring manager. Okay, well, I can only speak from my experience in all the interviews that I've done, or that I haven't actually done real interviews. Like I'm not in like a manager position. I'm not a hiring manager, so I don't ever do any hiring or anything. I'm not part of that process at my job. But in the interviews that I've been a candidate for, I've had lots of challenges like this. So I'll try to speak to that. So to be honest with you, the hiring manager isn't really gonna do much. But as a candidate, you want to ask lots of questions just to make sure that you understand what they're asking. The hiring manager is going to be keen on what kinds of questions you're asking, because that's how they're going to gauge your level of understanding. So, for example, If I were the hiring manager giving this problem, I would say the following. So I want you to, let's see here. One sec. Raina, right? That's how you pronounce your name?
Yes.
Great. So I'd be like, all right, Raina, welcome to Fidelity. That's where I work. But I want you to write a function that takes an object and turns it into an array of tuples. That's probably all they would say. And so you'd probably want to do a couple things. Like, if you're not sure what a tuple is, you'd probably ask, well, can I ask you what a tuple is? And I'd be like, sure. A tuple is just an array that contains two things, hence the name tuple. There's two of them. So, and then you could be like, all right, could I see an example of what an object being transformed into a tuple looks like? I'd be like, sure. Suppose I have an object, name and test, right? Here's an object. Okay. Oh, a tuple, a tuplified version of that would look like this. It would be an array of those properties. So name and then test. Does that make sense?
Yes. And if the hiring manager isn't doing anything or not doing much, they're simply observing and
Yeah.
answering questions.
They're observing and they're answering questions. And what they expect from the candidate is that you are really being vocal as you solve this problem. So if you are silent and you're just kind of staring at the screen, spinning your wheels, that's a bad sign, right? The hiring manager is going to be like, I wonder if this person actually knows how to code. Whereas if you're engaged with it, even if you don't necessarily arrive at the right answer, if you can give some insight into the thought process that you're going through, they're going to be like, oh yeah, like this person is obviously thinking about this in the right way. They didn't quite get the right answer, but their approach was correct. And given the fact that interviews are stressful and that you're under a time constraint, which is not how the real world actually is. Well, you're under time constraints, but you don't have someone hovering over your shoulder saying, all right, I need you to get this done in the next 45 minutes. That's not reality. So, a hiring manager is going to be much more, how do I put it? If they can really get an idea of your thought process, they're not going to care whether you get like the perfect answer or not. So let me, maybe it would help if would it help if I solve this problem as if I were a candidate?
Yes. Unless anyone else wants, something different. I don't want to
That sounds great.
the meeting. So
I'm curious.
I think this would be great. Also, we're like a little. I want to be mindful of time, so I think this is actually a really great idea. So I'm going to do it. I like it. So, all right. So, like I said, a tuple is just an array with two things in it. So when you tuplify an object, what that means is you basically are extracting the key value pairs and putting them into an array, and that's your tuple, or that's your tuplification. So, and if I were to, just so you can kind of see, if I have another property, then it's going to look like this. And you could, of course, see how this would continue. All right, so I'm a candidate. I'm given this problem. Okay. So now I think that, okay, so my plan is I know I have an object, so I somehow have to loop through the key value pairs of an object and convert them into a tuple. Okay, and then these tuples will then be added to the, the big array, the output array. So I'm going to assume that I've got some output here. Okay, and this is where I need to loop through. So I have to ask myself, okay, well, how do I loop through an array? Or sorry, how do I loop through an object? Looping through an array is easy, but looping through an object is a little different. There are things though called, there's a for loop that's specific for looping through objects. It's called a for of loop. So what I'm going to do, or sorry, a for in loop. So I've got here's my key. And here's my object. So I'm looping through all the keys in my object. And what I'm going to do is I'm going to then create my tuple. So I'm going to say tuple is equal to my array, which has two things in it. The first thing is the key, because like I said, or in my example over here, where I had name and then test. Right, so that's the key is the first thing. Okay, the second thing is the actual value itself. Well, you arrive at the value by referencing which key of the object I care about. Well, here's my object and here's my key. So that gives me my key value pair. There's my key, there's my value, boom, put them into an array. I've got myself a tuple. Beautiful. Well, now I've got my tuple. I can simply push my tuple into, I can push my tuple into my output array. Because again, I'm I'm converting an object into an array. Okay, and at the end of this sequence, I'm going to return my output. All right, so I'm now going to write some test cases for this. I didn't actually have time earlier to write some of these, but this will be helpful. So, all right, I'm going to make some cases. So there's a few important cases that I think I want to care about. So got my expected, and then I've got my inputs. Okay, so a few edge cases that I want to just kind of think about from the outset is, what if I pass in an empty object? Okay, cool. What if I pass in an object that has nested fields, such as I have a property nested that's also an object that has nested properties. I don't know, I'll do child test. Okay, and then let's just do a traditional example. So we'll just do A, B, B, and then C, C. Okay, so these are the three inputs I'll use. I've got an empty object, I've got a nested object, and then I just have a more typical case that would probably be the most common type of case. And I could, of course, add more if I wanted to.
I have a quick question.
Oops, and I put that in the wrong spot. Go ahead.
Have maybe in your company have somebody, I'm not sure how it works, but have somebody done a test at the same time, write the test, not just the solution, or there is no time for that?
It depends. when I did my interview, I didn't have to write any tests. I just had to pass the tests. So like I was running the tests, but I wasn't actually writing any of them. But I've also done interviews where I had to actually write a test as well, or write several tests for every, like I had to do exactly what I'm doing right now.
Oh, really? Good to know.
Yeah. It's honestly not as common though. I've only had to do that like once.
I mean, it seems very impressive if you do both. Like, it's like, oh,
Yeah, like knowing how to test your code, that's like next level stuff. Like that really is kind of, that is probably one major thing that differentiates maybe like a junior level developer from like a mid-level, is comfort with writing tests. So if anyone, or yeah, so I would highly recommend learning how to write tests. Cool. All right. So let's see here. So I know that if I pass in an empty object, then I expect it to be just an empty array. Okay. If I pass in an object with a nested property, then I simply expect it to be an array with, sorry, this looks a little messy. I'm going to try to make this look a little cleaner. So here's my tuple right here. So I know that it's going to be nested, and then this is going to be an object test. Because again, I'm just tuplifying. It's just whatever the value is. That's the value in that object. Beautiful. All right. And then lastly, I've got this guy. So this is just a series of tuples, A and A. And then this is B and B, and then C and C. Okay, so that's what I expect from these inputs. Okay, cool. So now I know that I need to test all these. So what I'm going to do is I'm going to loop through all my expected values. Or my inputs, it doesn't really matter which one I loop through. Okay, so here's my case. Here's the index I'm on. All right, so then I'm going to test output tuple. Okay, should output the correct tuple. I'm being lazy with my definition there, but that's right. Okay, and then I'm just going to say, okay, I got to make sure that when I call my function, I expect when I call my tuplify function with the input that I'm currently on, which of course is represented by the index I right there, I'm going to say cases dot inputs I to equal cases dot expected. Oops. Okay, this is what I expect. I've got a syntax error somewhere. Where is it? 39.
it's in line 44, the comma.
That doesn't make sense. Wait. Am I just tripping? I've been looking at a computer too long today. Unexpected token on line 39. I don't understand the problem. Oh my gosh. Okay, duh. That is a comma. That's supposed to be a comma. There we go. Okay, everything's fine. Bye, Emily. Yeah, hit me up anytime for
Thanks,
help
man.
on,
Have a good
on
one.
stuff. Yeah,
Bye.
for sure. Yeah, just Slack me whenever you get a chance.
Cool, thanks.
Yep. Okay, here we go. So now this should okay, it's still yelling at me. 47. Oh my gosh, no, that's right. Okay, that looks good. Everything is fine. Dude, I'm tripping out right now. I don't know why this is. Oh wait. There we go. Wait. Oh, right. Okay. What about now? Oh my gosh.
Sorry,
what?
I'm not that good in testing.
No, you're fine. It's the I just have a. It says I've got a syntax error somewhere, but I don't see where. I don't
Actually,
see
you're the
where
first person that showed me testing. So
Oh wait, there we go. Wait, is that it? Oh my gosh. Oh, okay, there we go. All right, everything's fine. I hate it when that happens when like you get like you accidentally delete like one parenthesis or you add one curly brace somewhere and it's like you're just going down a rabbit hole trying to find where it is. And the debugger doesn't always like give you very helpful information. Okay, cool. So we're good. Let's run the test. Let's see if it worked. Hey, it worked. Awesome. So to go back to this, all I did was loop through the object, create a tuple based on the each key and the value associated with that key in the object, and then push that tuple to an array. And at the end of that loop, returned that array, which leaves me with stuff like this, or sorry, this. Cool. Was that helpful, Raina?
Yeah, that was really helpful. Thanks.
Cool. Yeah, that's like one of the things that interviewers expect is you to be like very vocal and specific about what you're doing and why you're doing. And if you get stuck, that's fine. The key is to then try to explain what you think the problem is. And to kind of just like vocalize that process, because the better you can do that, the more impressed the interviewer will be, because they can't read your mind. So if you're just not talking, or if you're kind of talking nonsensically, then that's kind of a red flag. And to answer Ronald's question, does return object.entries object work too? Sort of. So object.entries is a cool little function. So suppose I have an object and I have like name test. Oh, holy shit. Yeah, okay, that's that just does it. I haven't used entries in a long time. I thought the entries only gave you the values, not the actual thing. So yeah, this literally object.entries is the actual, like that literally just does it. So we just wrote our own implementation of object.entries. So thank you for
Would
pointing
actually,
that out, Ronald.
actually, I have a question. I'm pretty sure like the questions aren't going to be this like simple anyways for interview. I don't know if they will be, but like, would they prefer you to write it out, like, you know, be able to write a loop of some sort, you know, to implement it versus like just using like a new ES6 or 2000?
It depends. It depends. Like, I don't, as long as you're just like talking through it and saying, I'm gonna use this, because it does X, Y, Z. Like for in this case, I could be like, well, object.entries will do this entire answer, or I can write it as, or I could explicitly write it as a for loop. They actually would probably be impressed that you know that. And then you could proceed to then do it both ways and be like, well, I could do it this way, but then the way, but then you can be like, well, just to prove that I know what object.entries is actually doing, I'll show you how I would do it this way. And then they'd be like, all right, cool. You clearly know what you're talking about. So there's benefit to doing it both ways.
What do you think? I will leave that for, I will do it the other way around. I will leave the object.entries as my second solution, even that I know already, just to show that that was my, what is it called? When you improve the code, I forgot, refactor.
Oh, optimize
Yeah.
or refactor, yeah.
Because if I do it the first right away that way, maybe they give me another question, harder question.
Yeah, for
So
sure.
maybe I have to give some time, and then the second time I do the other one, and then we go.
Yeah, that's a good point.
Brute force first, then refactor.
Yep,
Exactly.
that's probably not a bad idea.
I mean, somebody told me that when you answer an interview, you have to answer, you have to be like, you cannot give the answers right away. You have to take your time. When they ask you something that you don't know, then you won't be able, if you answer all the questions very fast, then they will know when you don't know. So if you take your time in all the questions, then they will never know that you didn't know something. That was something.
Exactly. Exactly. Word. Well, next week we're going to do this again, but we're going to do some harder problems. This was intended to be kind of a warm up, little beginner session. Did you guys feel like they were too easy, or was it like a good level for what it was?
I believe it's a great start.
Okay. Yeah, anyone else have any objections to doing harder stuff next week? They're not going to be like way harder, just a little more complicated next week.
Can I ask a quick question about testing?
Yeah, go ahead.
What is exactly the way you do the testing? Like, so I have, I guess, two questions. One is like you do first the solution and then the testing in real, or
so it depends. Like in proper test-driven development, in its pure form, you write out all of your tests and you write out all of the test cases, and then you write your code to like pass the test. That never works in real life. I'm just gonna be honest with you. I think that it's wise to consider your test cases first, and it's wise to at least write out the framework for your test first, just so you kind of, you know what you're testing for and what you're testing towards. But rarely are you going to just know ahead of time all of the edge cases and all that stuff. So like, to me, it's kind of a back and forth. Like I let my test inform how I approach solving the problem. And then as I actually do my coding and solving the problem itself, it informs what I'll have to test for. So it definitely is a back and forth kind of thing. It's you never write the test once in the beginning and then that's it. It just never happens that way.
Okay. My second question is, So I want to start building a project on the side, but I want to incorporate different things to practice. Testing is one of the things I want to incorporate.
Uh-huh.
I don't want to do testing everything because I don't want just to focus on testing. I want to focus on different things. So what would be your advice? Like, where should I put testing? Like, what is what is very, very important to have testing, and where it's not that important?
That's a good question. So it depends what your project is. I'm assuming it's like are you building like a full stack application, or are you building just like a static site? Like what's your
Yes, full stack application, like using the CRUD and all of those things.
Okay, so
Trying to have this sweet spot where to use testing.
yeah, so well, let me think. So this is always a really complicated question as far as like, what should you test? Like what should you test and what shouldn't you test for? Like obviously you don't need to test for every tiny little thing. It's just not practical. So what I would do is, especially the back end, I would focus on testing. Let me think. I would just test your basic endpoint. So I'm assuming you're building like a REST API, like with like maybe Node Express and like MongoDB or something.
Yes.
Yeah. So with that, I would recommend just trying to test your endpoints. And what I mean by that is like test that when I do a request to some endpoint, I get the right data back. That's the most basic test that you could run to like ensure that your backend's working properly, without having to worry about like, larger processes that you're testing for, like more like end-to-end stuff. Doing the endpoints, I think, is a good place to start on the back end. On the front end, that gets complicated. You're using React? Is that true?
Yeah. Yes.
Cool. So React is a really cool testing library I think it's just called React Testing Library, where you can test your individual components. You can also test your individual hooks. And now I don't think it's necessary to test every single component, although I don't know, at my job, we test literally every single component. What I would worry about is testing just major functionalities. Like if you have like, well, and yeah, like unit testing components that may have like a complicated set of methods or functions or something, like testing that the most important actions work. You could also use a library called Cypress, which is a end-to-end testing framework, which is really cool, but it's also kind of heavy, which allows you to basically programmatically, like automatically test the behavior of your application. So for example, like you could code a test that says, all right, load the page, enter your login information, check to make sure that it takes you to the landing page. That would be one example of an end-to-end test you would run. But I would just worry about unit testing the back-end endpoints, and then unit testing, some of the major components on the front end.
Sounds like, maybe I'm wrong, but sounds like the front end is more difficult to test than the back end.
Way more. Well, I mean, it depends on the project, but for like a typical just RESTful API with the front end, yeah, the front end is way harder to test.
Okay.
to be honest with you, testing the front end is a pain in the ass.
Good to know.
It doesn't like, it's just hard because it's so much more vague. A back end, you know, you have like specific endpoints that you like just expect certain things to happen when you ask it things, right? But with a front end, it's like there's so many things you can do. Like it's just so much, there's just so many more like there's just so many more possibilities on the front end.
You
And
say
then
you
the question, and then there's questions like, do you test things that work? Do you test do you test things based on how they look? Do you test things on how they function? Are you testing like specific processes? You know, step A, step B, step C. Like, there's just so many different things that are happening.
makes sense.
And you
This is
users, which are just you can't anticipate every possible thing that a user's going to do on your site. So that also makes it hard.
yeah. This is a silly question. You said you told us before that you at work you use TypeScript. Is that right?
Yeah, and actually, let me answer Ronald's question really quick.
Yeah.
Ronald, it totally depends. I know it's not a satisfying answer.
Oh,
Math knowledge is not necessary in most cases. I don't do any fancy mathematical stuff. The most complicated math I've ever had to do on the front end is converting a binary array into something else. Or no, it was decoding a binary array. That's like the most complicated thing I had to do. And that's not even really math. It's just zeros and ones. So now if you're doing more securities level stuff, or if you're like building a machine learning app, then obviously math is important. But typically math is not really that, you don't really use math that much. You do use logical thinking though, like you have to think mathematically in the sense that math is just applied logic. So you've got to, your logic and reasoning skills are vastly more important than your mathematical skills, in my opinion. And backend, I don't think requires any more or less math knowledge. Again, though, it depends on your application. If you are a developer working for Khan Academy, you probably should know math. But you know, it just totally depends. Anyways, so to go back to your question, Giovanni, about TypeScript, your question is like, so sorry, what is your question about TypeScript?
no, I believe it's a silly question, but TypeScript, do you use only Node.js or you use React also?
Wait, ask that one more time.
Yeah, I assume
you just cut out.
Yeah, I assuming you guys use React and Node.js. Is that right or wrong? At work.
Do you
guys
use
React
TypeScript on everything.
Okay.
Yeah,
so
Node and React,
my question.
everything.
Okay, so I don't know why, but I thought TypeScript was only for Node.js. TypeScript is also for React.
So TypeScript is not, it has nothing to do with what environment you're coding in. All TypeScript is a superset of JavaScript. So if you want your JavaScript to compile into React code, then cool, write your TypeScript so that it will convert into React code. If you want to do it in Node, then write your code in Node. It has nothing to do with the environment that you're writing it in. Now,
Okay.
technically TypeScript, technically you're using Node even when you're doing React, you're using Node to do all the fancy stuff. Node is basically you're essentially doing everything in Node anyways to begin with. So because TypeScript itself is a npm package. So like technically it's all Node anyways.
Okay, that makes sense. Yeah, I forgot because React is on top of Node.
Right, it's a Node library, it's a Node package, so like you can't really escape it. But like so but even if you just wanted to build like a static site that had nothing, that didn't do, you didn't use React or Angular or anything, like you just wanted to do just plain JavaScript, you could still use TypeScript. Just write your TypeScript the same way you would your JavaScript. It just compiles into JavaScript.
Good to know. Thanks.
Yeah. TypeScript's cool.
Yeah, ask a question, please. Is she there?
Hmm?
No, it's like, Mia, can you please ask one question? Because we are the only ones who ask questions.
Oh, I don't know. I'm bad at just thinking on the spot.
That's okay. I'm really, if someone was just like, hey Ben, ask me a question, I'd be like, I don't know. I don't have any questions on the
Yeah.
spot. I'm bad at that too. I feel you.
Oh,
Anyways, I hope this was helpful for y'all.
Yes, was great.
Yeah, next week we will be doing more of this. It will just be harder and more fun. It'll just be so much fun. I'm excited.
Nice. Somehow I am liking the testing. I like when you go from the solution to the testing and just type in the testing, like the basic cases that needs to pass. It's pretty cool.
Yeah, it gives you a lot of confidence. Like I feel that after writing these, I feel confident in my code. That's why I like testing.
Yeah,
So-
and I have attended a few meetups or workshops before, and everybody just focus on the solution. I mean, I never seen nobody to do the testing, so it's pretty cool.
Yeah, I find that's actually something that I was kind of like annoyed with when I was like learning. I was like, why is no one doing any testing ever? I mean, granted, usually there's just not enough time, but like, I don't know. I think testing is one of the most underrated and underappreciated aspect of programming. So I'm like a huge proponent of testing. It's not the sexiest thing in the world, but testing is incredibly important. Especially when you're dealing with an application that has like 500 files and it's being maintained by 20 people over 5 years. You know, you make one little change somewhere, and if you don't have tests that are like, if you don't have tests, then you have no idea what the implications are of your little change somewhere. You know what I mean? So that's why tests are important. And I'm going to do, I want to focus on, but there's kind of like two things that I'm just like really kind of obsessed with, and that's testing and TypeScript. Those are like my two like favorite things. So I'm going to try to touch more on those in the coming episodes as well. So keep an eye out for that. In fact, I might even just do like an entire like TypeScript series. So I'll just use this as like a, like we'll have the first episode of the series, we'll talk about basic TypeScript. And then the second week we'll do some more advanced TypeScript. The week after that is let's write a project in TypeScript and stuff like that. So it'll be like kind of like a little mini course on TypeScript. So that's kind of what I'm thinking of doing after the next 2 weeks. So I don't actually know if I have any after, wait, what is the date today? 16th. So I've got, yeah, next week is the last week I have, or next week is the last scheduled code talk on my calendar. I mean, they're every week, but I haven't, next week's the last one that I have an actual topic planned for. So I think after next week, I'm going to do like a full on TypeScript deep dive. Just, would that be something that you guys would be interested in?
Yes.
Yeah.
Awesome. Yeah, I've found TypeScript to be incredibly powerful, also incredibly frustrating, but also awesome. It just has a bit of a learning curve. That's all.
Hey Ben, can I ask a question?
Yeah, go ahead.
When did you like? Are you're a front end developer, or would you just say like more front end or back end?
In my day job, I'm doing front end, but I'm familiar with back end, I guess, stuff.
Okay. I just wanted to know like around what point, like I don't know if you went to a boot camp or these schools boot camp. Like what point did you kind of like figure out if you wanted to be like more front end or back end like focused, I guess, like as you're like what you're really good at? Because I mean, I guess like most boot camps teach you to be like full stack anyways, but then usually like when you get a job, it's going to be like front end or back end usually.
That's a good question. So I did go to boot camp. I went to V school. I also taught there for 2 years. And I've actually always much preferred back end. It's just that all the jobs I've had are front end. They seem to be more. There seems to be more front end jobs. I guess. I guess that's just how I've just always happened to fall into front end jobs. But so I just kind of, that's just the jobs that I got interviews for because I applied to lots of them. But to be honest with you, I much prefer backend. I would rather be rather be writing node servers and databases than writing CSS because I hate CSS more than anything.
Okay. Yeah. Oh, okay. Well, I guess my other question was then, it seems like more front end jobs are like available or like popular. Like how much in depth, like would you say that one should be, like you should be in CSS? Because I know like going into like most boot camps, I feel like they teach you a little bit of CSS, but they'll just like maybe like one framework of CSS, maybe like Bootstrap, or they'll like want you to be comfortable in that, but they don't really go into depth like CSS, like custom, like all those properties and stuff like that. Like as a front end developer, would you need to be like pretty comfortable doing all those custom CSS properties, or do you use more of like the frameworks and like have it all? Like how in depth do you need to be in CSS? I mean, like a wizard or like
it depends on the job description, of course. Like if you're gonna be if you're gonna be like building a UI library or something, the better you are at CSS, the better. But like to me, CSS, at least in my experience, CSS has been the least important skill. In fact, no one even in all the interviews I've done, CSS was never tested. Like I was asked questions about CSS, but I was never asked to demonstrate any CSS knowledge, which is kind of interesting. They are always asking JavaScript questions. So CSS is actually, at least in my experience, from an interview perspective, CSS is the least important skill. Now, if you're interested in CSS and you like CSS, then just, get good at it. You know what I mean? Like there's a lot of, I mean, honestly, CSS is probably my weakest, point as a developer, because first of all, I hate it because it doesn't make any sense. And I'm not a designer, I'm not an artist. So like making things look good is not what I care about. I care about how things work and why they work and the logic behind it. I really don't give a crap about font size or pixel size. Like I just don't care. So like CSS is not a high priority in most cases. Obviously you need to have a working understanding of it. Like you can't not know CSS and become a front end developer, but like gaining mastery over like Bootstrap or Angular UI or something is certainly helpful. But if you're interested in CSS, like I've always been a proponent of not worrying so much about what you should do or what you shouldn't do. Because I get asked that question a lot, actually, which is like, should I do this? Should I do this? Should I focus on this? And I go, well, the problem with asking the question, what should you do, is that every job is so different that you can't possibly prepare for every scenario. Like I got a job working in Angular when I'd never worked in Angular before. I've been doing React for 3 years and I got hired, and then I find out that they do Angular. So I didn't do any preparation whatsoever for Angular because I had no idea they used Angular until I took the interview. They hired me anyways. So I wouldn't worry so much about what you think you should or shouldn't do. Just follow what is interesting. That's what I've always done, is if there's something that I'm curious about or I'm interested in, I'm just gonna play around with it. Because to me, coding is just a big playground. And so I just find joy in taking an idea and playing around with it and just building stuff with it. And then I learn in the process, and then I don't worry about whether I'm learning the right things or the correct things. It's just, am I learning and am I enjoying it? Then I'm happy. And it is reflected when you go into an interview. So that would be my 2 cents on that.
Yeah. Okay. Yeah. Because I don't really like CSS too much either. It's just like, I didn't know like how. I guess like if what the amount of focus I need to put into it, like if it's even like relevant, if you learn like React and all that stuff. Because, I mean, I'm not really at that point anyways, because like I'm just trying to like get better with HTML, CSS. Like I'm pretty comfortable with JavaScript, but my CSS is so weak. It's just like I try to
Yeah.
So it's like kind of like level, like even.
Yeah. What I would recommend doing is at least coming up with gain at least a solid enough understanding of CSS that you're still doing best practices, such as, not duplicating your styles all over the place. It's well organized. Your responsiveness is really important. Being able to have your app look good at various screen sizes.
Okay.
And having it and being able to apply like themes and general stylings.
Okay.
That's what I would recommend, because just like JavaScript, you want to write code that's maintainable and understandable, but also efficient and also easy to read and easily organized, but also easy to maintain. You want to at least gain that similar level of understanding with CSS. But you by no means need to be able to like know how to write a let me think, what are those called? Totally just like you don't, it's not like you need to know how to write SVGs from scratch and stuff like that. Just being able to write well organized and easily maintainable responsive CSS is, I think, the minimal expectation for a front-end developer.
Okay. Thank you.
Yep. Word. Well, guys, thanks for joining in. I hope that was helpful.
Otherwise, thank you then. See you.
Yep. We'll see you guys next week.